Hello and welcome to today's live webinar, BIMQ for Advanced Users. This webinar, BIMQ for Advanced Users, is our follow-up webinar to the webinar BIMQ for Beginners. So if you haven't seen this webinar yet, you should definitely watch it. Today we are not looking at the basic functionalities of BIMQ. We are looking at specific workflow processes and extended functionalities. How can we work more efficiently in BIMQ? But first, let's look to our agenda. And first, I will give you a short introduction about myself and of the company which I am employed. After this short introduction, we go straight to the practical part, the live demonstration, and we look at the following topics. The first topic is the Excel import-export service of project data. Mostly project data is already documented in form of Excel spreadsheets. And here we want to look at how we can import this data fast and efficiently into BIMQ. The second topic is access to external content. If I am invited to participate in specific projects, I'm able to transfer the content of this project to my own project. Next, we will also look at a new import process for importing project data into BIMQ. And here we will look at how to import project data from IDS files or from IFC files. The next topic concerns the IFC configuration. What possibilities do we have here in the IFC mapping for elements and for properties, and how do we use it in the IDS verification? And here we will also take a closer look to this checking process. And for the final topic, we want to look at the functionality of data drops. That means project data or informations that we required at a certain point of time. About questions, please ask questions in the area provided for this. We will answer them at the end of the webinar, and questions that cannot be answered in time, we will answer later by email. Okay, shortly about myself. My name is Florian Fliegel. Since 2020, I'm employed by the company AC3. My typical tasks are the classic BIM management. I'm the product owner from our data management software BIMQ, and I'm supervising the field training and education. About the company AC3, the company has been providing BIM management services for over 20 years. In general, we cover three specific teams. First is the BIM management. This includes strategic development for clients, creation of line definitions or quality checks. The second field is research and development, and this is about standardization, IFC certification, recommendations, and expert reports for customers or research projects. And the third field is our data management platform, BIMQ, where we can manage our line definitions and in which the data can be further used in form of software templates for different authoring tools or for the output to checking rules. Okay, let's don't waste time. Let's move on the practical part, the live demonstration. And now you can see the user interface of our data management software BIMQ. And for our example in general, we are using the administration building see here. It's a typical project with typical information requirements for an architectural model or for an structural model. And we are starting with our first topic, the Excel import-export service. And if you want to add new content or new data into BIMQ, you can use the user interface in BIMQ, but you can also use the Excel import-export service. And we provide the Excel import-export in all main areas in BIMQ. So you can use it to add new actors, you can use it to add project phases or use cases, and you can also use this to add content to the area of the library, the component templates, to add, for example, objects or properties. What you can also use is the function in the area project setup. And in this area, you can import a linking structure. What elements are linked to specific discipline models, or what properties and property sets are linked to the specific elements. In our example, we want to use the Excel import in the area of our library. And we recommend that the first step is that you export an Excel template. This is because you get the correct structure, the correct library structure of your project, and you can also define what mapping specifica do you want to export. If you want to export an Excel template, it's quite easy. You go to the tab Excel Import Export, and here you have the two possibilities to import an Excel or export an Excel. First, we want to export an Excel file, and here we see our export configurations. We see the component types, and maybe we say we want to export the discipline models, the objects, and maybe the properties. And you see the component types are the same like the hierarchy structure here in our library. What we want to export furthermore is our data types, and maybe we want to export the IFC schema for IFC4, and maybe the Revit configuration. Now we want to export it, and we are looking at the results. One moment. And here we see the exported Excel template. We see the different component types, discipline models, objects, and properties, and the exported content. For our example, we want to add new objects in our library. We want to integrate them in the MEP area. And maybe we want to create a sensor, a damper, and a duct silencer. If you know the right mapping, you can also add the mapping for Revit. I say it's a mechanical equipment, and furthermore, I add the IFC mapping. So for a sensor is IFC sensor. The damper is IFC damper. And for the duct silencer, it's easy, is IFC duct silencer. And for the IFC mapping, I create a spelling error. I write IFC duct silence, and we want to look how BIMQ react to this spelling error here. Okay. It's furthermore possible to add more content in form of property, new properties, like the same way what we see by adding the objects. But for this example, we want to concentrate to the new objects here. We save the Excel, and now we import it back to BIMQ, and looking at the results. One moment. And now we got a warning message. Okay, I had another spelling error. First, we get a warning message to IFC, uh, IFS sensor. So it's a spelling error, and IFC duct silencer. So this IFC mapping is not integrated in BIMQ because the wrong spelling. And we get 7 added concepts in the area of objects, and we look at the results, and we see here in the MEP model, we see we have added the right rabbit mapping and the right IFC mapping for the IFC damper, and for the duct silencer and sensor, we had to complete the mapping in the user interface. So I'm searching for duct silencer and for the sensor. And now it is correct. So in common, this Excel import-export service is the very fast and efficient way to add a big amount of data fast and efficient into BIMQ. You can use another functionality to import a big amount of data in your project. And this is about topic 2, the access to external content. And we provide these functions in the area of templates and also in the area of project requirements. We want to look first at the templates access to external content. And here you can go to template import, and here you have access to every project which you are invited. So here you see every invited project or project that are public. And for our example, we want to use the catalog templates in English and look at the results. Here on the left side, we see the content, the library structure from this catalog templates in English. And on the right side, we see the requirements or the library structure of our project. And if you want to add new content from this project here, it's quite easy. Maybe we add new elements, for example, this folder here, distribution control elements. And you see here, this sensor is crossed out. This is because we already have a sensor here. It was a new element what we are created. And to yeah, that we don't add and duplicate, we cross it out. Okay, we say we want to add this complete folder to our own project. We can use the drag and drop function and add it to our project, including all the mapping to IFC or to a specific authoring tool. The same way you can use it for the properties. For example, if you want to use these 2 property sets, you can also add it to your own project. So this is a very easy and fast way to use external content or public content that we as AEC3 provides. Okay, on the area of project requirements, it's quite similar. For that, we will look at the structural model here, and we want to add content maybe from another project here. We are using BIM-IDS. It's a project exchange requirements from Luxembourg and Belgium. So it's another public project provided by AEC3. And here we want to look at the content of this project here. And here we get also the linking structure. That means what properties and property sets are linked to the specific elements and linked to the specific discipline models you see here. And we are looking to our structural model, and maybe we want to add the foundation beam. And here maybe we say we don't need all property sets. We want to add only the global geometry of this element. And later, it's also possible to add um, more content. For example, where was my foundation beam here? Maybe I want to add this property set. So what you decide is what you get. Okay. The next topic is another import function that you can use, and that's a new import function to import project data from an IDS file or from an IFC file. And to show you that, I will use a specific project for this. So an empty project. In this project, I will import this information, but it is also possible to import IDS information or IFC information in your current project. But for the better understanding, I decide to use empty project for that. So we see we have here no content in this project. We have only two discipline models. The first discipline model is called IDS import, and the second discipline model IFC import. And these models are all also linked with a placeholder and have no content in there. Okay, we are looking first at the IDS import. And now when you have an IDS file, you can use the information in this IDS file to import the information requirements to BIMQ. To use that, you can use the tab here, IDS IFC import. And here we have the two possibilities. First, the import of an IDS file, and second, the import of an IFC file. First, we want to use the IDS import. You choose the IDS file that you want. One moment. And for that, we use an IDS file. So, okay, where is it? So, here. And now we are looking at the results. It's take a few seconds. And in a few seconds, we should see the result of the import from the IDS file. Okay, here first we get an information what we have imported. We imported 51 different element types and 576 linked properties to these elements. And now we see the results here from this IDS file, and you see it's a very fast and easy way to use the informations of a standardized IDS file. So for example, we are looking to this column here. We see the IFC mapping that we have imported, and we see also when there is a description. We imported the description, and we imported furthermore restrictions in form of constraints for enumerations, patterns, or ranges, for example. And here you see we also detected the right mapping. So when it is used as a direct IFC property, we have the link to the IFC property. When it is a user-defined property, we marked it as a user-defined. And when it is an IFC attribute, we also detect it as an IFC attribute. And it's the same with base quantities, or even with IFC classification and IFC material, for example. Okay, let's look to the second import possibility, the IFC import. And for that, we have an extra discipline model, the IFC import. We see it's a um, um, it's a model with no content here, only the placeholder take place. And now we want to import an IFC file. And you can use every IFC file that you have as a reference. And for our example, we want to use a specific discipline model. It's an MAP model. And this IFC import, it takes a longer time because we have to analyze the IFC model, and we have to structure the data in this IFC file. Okay, maybe we want to look what we want to import in BIMQ. So we import the information requirements of this MEP model. It's an electro model with typical elements here. We have cable carriers, cable carrier fittings, electric appliance, electric distribution boards, or some objects, some proxy objects here. And maybe we want to look to an distribution distribution board. So this is marked as IFC electric distribution board. We see here a predefined type, a used predefined type. It's called a distribution board. And we see IFC properties are linked to this IFC distribution board. And we see also user-defined properties here in the property set pset MEP. Okay, let's look back to BIMQ, to our results, and it's now importing. And the time that BIMQ needs for the import is according the size of the IFC model. I think we need 2 minutes to import this data here in BIMQ for the size of that IFC model here. Okay. But it should be finished in a few seconds. And here we get the results. We see we imported 20 elements, 20 different elements with 82 linked properties. And we see the results. And for that IFC model, we don't use the IFC 4.3 schema. We used the IFC 4 schema. So it's created in IFC 4, and here we see the correct mapping. So maybe we should look to the IFC electric distribution board. We see here the correct element mapping, and also the correct mapping to the properties. We have the link to the IFC properties and the link to the user-defined properties. And what we also imported is, of course, the data type. And when there is a constraint, we also use it, for example, ranges or enumeration lists. Okay, let's go to the next topic, and the next topic is according the the IDS verification process. And for that, we use as an example the architectural model here. We see we have typical information requirements of this architectural model. So we want to check space, we want to check external and internal walls, and we see here we differ between external and internal walls. The difference is in form of the IFC mapping. So for external walls, we define it as an IFC entity, IFC wall. But here we use further two classified properties. The first property is external. External should be true. And the second property for that is load bearing. And load bearing should also be true. When we look at the internal walls, we marked it as an IFC wall entity. And here we use the classified property is external, and we say is external should be false. And in this way, we differ this specific wall definitions. Okay, we had another requirements for curtain walls, base walls, floor slabs, roofs, columns, stairs, windows, and we differ between two type of doors, single doors and double doors. We have another specific definition here for the material definition. We want to look at a second time to this specific definition. And first, we want to concentrate to the basic requirements here. Okay. I have created specific checking rules for our example. For example, for spaces, I have created a regular expression so that the room number follows a specific schema. My schema says the room number should be start with GO, and then I have a 3-digit from 0 to 3, then followed by a point, R for room, point, and then I have a 3-digit from 0 to 999. This is my schema, and I want to check if the room number follows this schema. Another specific checking rule what I created is, for example, the net floor area for this room. And here I say the net floor area should be bigger than 5.5 square meters. What I have defined furthermore is for external walls. And here for external walls, I create common property for thermal transmittance. And for thermal transmittance, I have added a range as a specific IDS configuration. And my range goes from 0 to 9.0 watt per square meter Kelvin. So this is my range, and all values should be set in this range here. What I have furthermore defined is the base slab. Here, a base slab is also is external true. So I have say it should be true. And for the roof, I make a specific requirements. We want to check IFC classification. So I set this property here of IFC classification, and we want to check, no, that's the wrong one. We want to check the IFC classification for the uniformat. You can use IFC classification for all classification systems. Important is that the classification system is marked in the IFC model, is defined in the IFC model, and when it is defined, you can use it. And in our example, we want to check the IFC roof elements to the IFC classification uniformat. Is it set or is it not set? And the same for IFC material. Here for the roof elements, we required IFC material for all roof elements. Okay, we want to export these requirements in the project phase 5 in the use case minimum requirements. For example, for the property mapping, here you have the possibility to decide between different mapping methods. You can map to properties, IFC properties, or user-defined properties. You can map to base quantities, IFC attributes, or to IFC material, or to IFC classification. By the properties, you can decide if you want to use a dynamic IFC definition. That means this property knows what is the correct property set when it's linked to the right element. So, for example, is external is linked to this wall in this example, and the right property set is pset wall common. And the same property is linked by the slabs, maybe fire rating to the slab, and the right property set is pset slab command. What you can also use for the properties is fixed property definitions, like here. We use here the fixed IFC definition. So this property is linked to the property set pset concrete element general. And you can also use individual user-defined property definitions. And here we have a user-defined definition. Okay, we want to export this information requirements and looking at the results. So for that, we go to documentation, checking rules. We want to check to IFC4, only the minimum requirements. And now we are exporting an IFC file. We save the IFC file. And now we are looking to our example. For that, we delete our electro IFC model. And we are open our example model that we are used for our project. Okay, this is our IFC model, and we want to check if is the requirement structure, are the requirements that we are defined in BIMQ are in this IFC model. And in the next step, we are importing our IFC IDS file that we are created for a few seconds. And here you will see the IFC rule set for spaces, external walls, internal walls, base slabs and floor slabs, etc. And now we want to check and want to look at the results. Okay, we get some issues. The first issue is on spaces. And here, first we check the net floor area. And we remember, we say the net floor area should be bigger than 5.5 square meters. And here we have one room that's smaller than 5.5. And we are looking to the quantities. Net floor area, where is it? Here is the net floor area, and we detected here 5.21 square meter. So here our checking rule is marked correctly. Another issue is our room number. And here we have more issues, more failed room numbers, but you see some rooms should be okay. And to see what rooms are okay, we can go to the check components. And here we have the possibility to show what components are okay. And we see here, okay, we have here some rooms that follows the right room schema. And we see when we are looking to the room schema here, number, it's the right room number. It's starting with G02.R.236. And when we are looking back to our schema, then we see this room number follows our schema. When we are looking to the failed elements, then we see, okay, here we set another room number, and that's are all issues. Yep. So here also the IDS checking will works correctly. Okay, let's look to another issue for external walls. And here we had the issue for terminal transmittance for the wall. And we remember the terminal transmittance should be in a range of 0 to 9.0 watt per square meter Kelvin. And when we look to the value, to the set value, then we see it's 9.1. So it's bigger than 9.0. And here the IDS checking rule also works correctly. Internal walls are correct. Then we have curtain walls. Here we have typical issues, typical warning messages, and it says invalid cardinality. So that means the properties here are missing on this curtain wall. So this two properties is extended warranty or manufacturer is missing on this curtain wall. Base slab is okay. Floor slab, we have another issues, and here we see, okay, something went wrong. It should it seems that we get here roofs also. Yes, we get roofs, and when we look to the roof and look to the IFC mapping, we see, okay, it's an IFC slab with the predefined type roof. So Solipre marked it as a roof, but it is not really a roof. It is also a roof, and here we have an issue in the IFC mapping in the IFC file by himself. So we have here duplicates. We can see it on the bed ID. The bed ID of this IFC slab is the same like for the IFC roof, and that is a very important information to detect duplicates in an IFC file. Okay, so that's direct duplicates, and what we also see on this checking process is these landings here, and this is a typical problem for the checking process, a typical issue. The most authoring tools cannot differ by stairs in IFC landing in this IFC slab landing types to an IFC stair. They cannot differ. That is one element, and Solipre detected as it is two elements here. You see, here we have an IFC slab, but it is part of an IFC stair. And this is a typical problem. So in this checking rule for floors, we check the IFC, the landing elements here. We check it. We can use BIMQ to specify our checking rule, and IDS don't allow us to exclude predefined types, but we can define what's included. So for the floor slabs, maybe we can say included are the predefined type floor, and we don't want to include the duplicates, the roof elements. We don't want to include the landing elements. For the base lab, we had a specific rule set, and maybe we want to include not defined. And here it is further possible to include specific user-defined predefined types, but in our example, we have no user-defined slab elements. Okay, we say we want to only include floor and not defined elements, save it, and we create another rule set for this example, and we are looking to our results. Save it and go back to our Solipri model checker. We remove the old rule set. Now we make another check, and here we say floor slabs are marked in green, so everything seems okay here. Okay, let's look to our roof elements, and for the roof elements, we have the first issue is to IFC classification. We remember we checked for IFC classification for the classification system uniformat. One moment here. This is required. We required IFC classification for uniformat and IFC material. And for IFC classification, we had a warning message. These roofs here have no entry to IFC classification. We look if it is true. We see here the main roof, and here under classification, we see no entry for the uniformat, and it's the same with the other IFC roofs. But we see we had another roof here, and when we look to classification, we see a classification to uniformat with the reference B1020. So we get the right value. And here we don't see that is here an issue. The next is IFC material, and we check IFC material. We look if we have an entry to IFC material, and we see IFC material is empty. It's the same like here, material is empty. But for the main roof, we are looking for IFC material, and here we get an entry IFC material, and here we see an IFC material in this area. Okay. The another properties are typical properties that are missing. For example, is external is missing for here. Yeah, and we see only references detected. Okay, let's go to the single doors and the double doors. And here we see it's not checked correctly. Under single doors, we see the double doors, and under double doors, we see the single doors. So everything, some checking rule run into an issue, and we are looking back to BIMQ. What is the issue? The issue is that both door types is marked as the same IFC class. So we get no difference here, and that's the problem. We had to differ this between these two door types, and we are going back. What can we need? What can we use to the difference of these two door types? We can use IFC standard properties, maybe the reference parameter. It's called here single doors. And when I look at the double doors, then I see here the reference parameter, the value is double doors. Okay, we can use this as a filter criteria. We go back to BIMQ, and we define it as a classified property. Use reference, single door. Oh, and the same property for the common, for the double doors. Okay, yeah, it's correct. And now we export another rule set. Project phase 5. I save it, and we delete the old rule set. And we check, and here double doors are okay, and we have one issue on single doors, the fire rating. And when we are look, okay, the message says we using the wrong value. We are using for fire rating the value F90, but we have to use an enumeration list. We have to use the T classes, T30, T60, T90, or T120, and so we get these issues here. Okay, let's look to the last definition, and this is a special definition, a material definition. And here we want to check according to an material, my material called reinforcement concrete. So I want to check all elements that are marked with the material reinforced concrete. So for this definition, I using another mapping method. So I say I don't use the mapping method with entities. I use without entities. IDS give me the possibility to do this, and here I created a classified property, identification material, and my material should be reinforcement concrete. Okay, and when I look to maybe this roof here. Okay, no, to this wall maybe. I see here the material name is reinforced concrete. So I want to check all elements that are marked with reinforcement concrete. Okay, let's do this. I will require these properties. We want to look have the reinforcement concrete elements the properties exposure class, straight class, and we want to look at a specific base quantity at the net volume of these elements, and we want to check if net volume is available. Okay, we have required, we take another rule set for this. We save it, go back to Solipri, remove the old rule set, and here you see the added rule set for reinforcement concrete, and we want to check, and here we get some issues, and we are looking for these issues here. Okay, we had an issue for exposure class. So, okay, it seems that all columns have no exposure class, and also the roof. We are looking, is it right? IFC properties. Here, PZ concrete element general is missing completely. And for the columns, we have the PZ concrete element general, and exposure class is missing. We see it. Okay. So this checking rule works correctly. We are looking to straight class, and here we see all columns have the straight class. But when we are looking to our roof, yeah, the PZ concrete element general is missing, and it's the same with the slabs or with the stairs. Here, the property straight class is missing by the stairs. Okay, and we are looking to net volume, and here net volume is missing on this properties here. We are looking to the roof, and we see, okay, net volume is missing by all these elements here. Okay, that was our specified checking configurations and our example. We go to the last topic, and the last topic is data drops to create checking rules for specific requirements in a certain point of time. When you want to use it, you have to create first data drops. For our example, I will create two data drops. The first data drop, yeah, we call it data drop 1, and this data drop is required on the 1st of April, and we want to use another data drop for, it's called data drop 2 for the 1st of May. And now I can link specific combinations from project phases and use cases to the different data drops. For example, in the data drop 1, I say I want to check the minimum requirements in project phase 3, And in data drop 2, I want to check the minimum requirements in project phase 3, and furthermore, minimum requirements in project phase 5, the visualization and the model coordination also in project phase 5. And now, if you want to create tracking rules, you have the possibility to use it as a data drop. You can choose the different data drops that you are created. And for my example, I will create checking rules for the data drop 2. I want created it in IFC4, export it, and now I get an zip file with 3 different IDS files. The first IDS file is for our architectural model, then we have our MAP model, and a third IDS file for our structural model.